This is a video on serial dilution. Serial dilution is useful when dilution cannot be done in one step. This occurs when the glassware is not large enough to carry out in one step. For example, how would it be possible to carry out a 100,000-fold dilution? In one step, this means that 1 ml of sample must be diluted using a 100,000 ml flask. In a serial dilution, a diluted sample is again diluted, and it could be done several times. Here is an example of a serial dilution. In this example, you will notice that several volumetric flasks are used in the process. The technique for diluting using these volumetric flasks have been previously described, where after adding the aliquots, water is added until the meniscus of water is in line with the line marking of the volumetric flask. Then a piece of paper towel is used to absorb the clinging water droplets just above the surface of water. The flask is then capped and shaken to mix. In this example, we'll start with a beaker containing a stock solution of 2 mole per liter sodium hydroxide. To a 100 ml volumetric flask, 1 ml of 2 molar sodium hydroxide was transferred by pipette. Water was then added, and the diluted concentration of flask 1 was determined to be 0.02 mole per liter. From the stock solution to flask 1, this is the first step. From flask 1, 1 ml aliquot of 0.02 mole per liter, the diluted concentration was drawn out with a pipette and transferred to an empty and clean 100 ml volumetric flask. Water was then added. The diluted concentration of flask 2 was determined to be 2.0 times 10 to the minus 4 mole per liter. From flask 1 to flask 2, this is the second step. From flask 2, 10 ml aliquot of this solution at a concentration of 2.00 times 10 to the minus 4 was pipetted and transferred to a clean and empty 100 ml volumetric flask, and water was added. Flask 3 concentration was determined to be 2 times 10 to the minus 5 mole per liter. The dilution factor of each step can be determined from stock solution to diluted solution in flask 1. The dilution factor was 100-fold by dividing the high concentration stock solution over the diluted concentration in flask 1. Similarly, the dilution factor from flask 1 to flask 2 was 100 times. This was determined by taking the concentration of flask 1 divided by the concentration of flask 2. And from flask 2 to flask 3, this was only a 10-fold dilution. From stock solution to flask 3, the dilution factor of stock solution divided by the diluted concentration of flask 3 give a dilution factor of 100,000. Alternatively, by multiplying the dilution factor for each step, this also gives 100,000-fold dilution. From flask 2 to flask 3, this is the third step, and all the steps combined gives this process a serial dilution.